Hello everyone and welcome to yet another video. In this one we will be implementing another data structure in the base.h file because I really want to start building a tool for building our project. Since we currently only have a shell script for both the app and the stuff, this is just temporary obviously, but we in the previous episodes we were able to add the raylib and libuv dependencies, third-party dependencies, and link with the necessary Windows libs, right? System libs. But I would like to have a building tool to support multiple platforms like Windows, Linux, Mac OS, and so on and so forth, and to be very easily to and to be very easy to integrate with all of the different platforms and compilers. Since we are using the C standard C23, we can use multiple C compilers if we want to, right? And to have this tool, right, to have this build tool that is going to be written in C, I would like to have one extra data structure, and probably the final one, and that is a dynamic array, a generic dynamic array. So this is going to be very simple to implement. It's going to be similar to everything we all have already done previously. So we can come to this bucket list, so we can define it in here. For example, I can do a similar thing like we have done everywhere else. So I can say, I think I'm just going to call it array instead of array, dynamic array. I think this is just fine because everyone that sees this is going to understand what this is. Or I could probably call it a slice, but C programmers, they are not really familiar with that term, slice, and that's more of a modern term probably. I don't know, I'm just going to call it array for now. I can always change the names obviously. Okay, so here I can also copy paste this. It's not really that different, so I can simply say this is a type name. Here we are going to have the type, and we are going to have data, and this is going to be a pointer, and here, yeah, this needs to be yeah. So here I can have a size t for the length and the capacity. So I can call it length and cap, and I think that's everything, to be honest. So let me just line up all of these slashes like so. Okay, and this actually needs to be indented, yeah. And I don't think I'm going to need anything else in terms of the declaration, so I don't need this last slash. And then I probably just want the append for now, so I can say define array appends, and this is going to be similar to whatever we have here. So this is going to be a list and an elements. Actually, it's going to be an array and an elements, and here I can just well, this is probably going to be different, so I'm going to implement it by end instead of copy pasting. So same stuff as always. We have a do while loop. Inside my do while loop, first we need to check if the well, we have a few standards, right? Because this is just for just for the for each. So here we just need to check if the array length is greater or equal to array capacity. Then we need to reallocate the data, right? So we can simply say that array capacity is going to be equal to this. So if the array capacity well, we can have another if, right? Well, yeah, because I want this to be properly aligned and to be a power of 2 if possible. So we can just say if the array capacity is 0, then we can set it to be what do I want to be the initial capacity? Let me think. Probably 2 is a good number. I can always change it, right? So it's not a big deal. So we have 2, and if the array capacity is not 0, then we can simply multiply it by 2, right? So it's going to increase in the powers of 2. So let me just add the necessary slashes. So okay, so why is this? Okay, so this, we incremented the capacity. Now we need to reallocate the data, and to do that we can simply say array array data is going to be equal, and actually here, oh, this is very interesting because we are going to need another stuff like this. Very interesting. I need to refactor this in the future, but I'm just going to implement the array for now. So I can just call it array, and here I can just say array options. Alright, array options, and then in my array I can go to options, and I can say allocator. And what is this allocator? So this is the allocator, and I probably want my allocator to also implement realloc, right? Just to facilitate my job. So this is realloc, and the signature of realloc is going to accept the allocator. This is going to be the old size bytes, and then, oh, what did I just do? And then I just need a new size bytes, right? So I can just say new. So this is the old and this is the new. So inside here I can just say that size t old size bytes is equal to the current array capacity times size of the element, and the element is going to be array data, and we can dereference that, right? So this is the old size bytes, and the new size bytes is going to be very similar. It's basically the same thing, right? Just the same thing, but after we incremented the capacity. Okay, so this is just to properly align it. So here in allocator we can simply call realloc, and in realloc we can pass array data, we can pass old size bytes and new size bytes, like so, and you can probably just format this a little bit better, like this. Okay, so I can add slashes again, so the macro properly inlines all of this. This is going to be like so. Okay, and I need actually another slash here. Okay, so this already is going to assert that data exists, and this is probably everything we need for now. So in this if, we just reallocated the array itself whenever we don't have enough capacity to append an element, right? So now what we need to do is to actually copy the element. So we can say array data, then array length, and we're going to set it to elements, like this. Very simple. And finally we need to increment the length of the array, like this. So this is probably the entire implementation of array append. I don't think we need anything else. We could probably inline this just to be a little bit for it here, I guess. So this is array cap is equal to array cap equals 0 question mark if 2, otherwise this. Yeah, it fits on a line properly, so we can do that. Okay, and we saved a few lines. So yeah, we are not going to need anything else here. And here I can just say array for each, like this, and you can pass the array. I can pass the array, and I can also pass the code, right? The code, oh, like this. And here, same thing as always. So do while loop. Okay, and what we are going to have inside here. So this is probably going to be one of the simplest implementations. For each, because here we are just going to need it index equal to 0. Then we are going to check if it index is less than the array length, right? And then we just increment it index like this, and this is already super simple. Okay, so inside here we can inject code, the code that user provided, and we are going to need to also define, obviously, the it implicit variable. Let me just add all of the slashes so the macro is happy. Okay, so we are going to need to define the implicit it variable, and to do that I can just say type of, and the type of is going to be type of this data, right? So I can just say array data, and since data is already a pointer, well, but let me just be explicit and say this is a type itself, and I want a pointer to that type. Okay, so this is more explicit of what I'm trying to do, right? And it tells whomever is reading this code, it tells exactly what is the intent behind this, right? It literally says, yes, I want this to be a pointer to data. Okay, so here I just need to say that it is going to be equal to array data at index its index, and I want a reference to that, like so. Okay, and I think that's everything, to be honest. So I don't think I'm going to need anything else. So if I go to my, I don't know, this file, we already have 3 different files. Yeah, this is just temporary, of course, just to test integrations, third party and demo and stuff like that. We're going to clean up all of this in the future, don't worry. Okay, so I don't really need this because this is already covered in the demo, right? So this is just my test file. So I can declare an array, and I'm going to say that this is an array of sharp pointer. I'm going to say string array, right? So this is going to be a string array. So this is my strings, and here I can just say array appends, right? Array appends, and this is complaining about something. Okay, so we are going to need to fix it. Let me just say here array for each. Does this complain? No, so this is correct. Okay. And here it actually expected a semicolon. That's very interesting. Why did it expect this? Oh, because my for each is, yeah, let me just remove the semicolon here, because I actually want to place the semicolon to be like more in line with the C syntax, right? So here I can just say semicolon, and this is actually like it follows the C syntax, right? But here we have something complaining. Let me check. What is it complaining about? So, okay, so it is complaining here. Expression must be a modifiable L value. What are you talking about? So that's very interesting. So I can say something like this. Let me just check. Oh, I over selected stuff. Yeah, it's also complaining. Okay. Let me just, oh my god. Okay. I'll need to move it by end. So this is the first thing it's complaining. Why is that? So that is very strange. So if I say something like this, strings.cap, why are you? So I can say something like this. That is so strange. What? That is very weird, to be honest. Can I put it in an if statement? So if cap is equal. Yeah, this no longer complains. Did I just make a mistake somewhere? Okay, so here, where is it? Here. Yeah, I don't think I made a mistake, to be honest. I don't know why it is complaining about that, but I guess I can put it inside an if statement like we had previously, but that's very strange. Anyways, that's easily solvable, so not a big deal. Else we do something else. Okay, so here I can just say this times equals 2, and here I can just say 2 like this. So this should fix the first problem. Okay, a lot of slashes that these macros require, right? Okay, so this should fix the first problem, and now type allocator. That is very strange. Let me just see the expansion of the macro to see what it is complaining about. It's something to do with allocator, but let me check. So, okay, it's complaining here. Expression must have struct or union type, but it has type allocator pointer. Oh, I see, I made a mistake here. This needs to be an arrow, right? I believe that needs to be an arrow. Yes, it is working now. Okay. So because, yeah, the allocator is a pointer. So now we just need to implement realloc, right? Realloc. And actually, I can implement realloc the same way I implemented this here. So I can say realloc, I pass the allocator, I pass the old size and the new size, and instead of calling the allocator directly, instead of calling the allocator, where is it? Instead of calling the allocator directly, I just can say realloc and pass the allocator pointer. Yep, like this, and then pass the. Yeah, I probably need to pass. Do I need to pass the old pointer? Well, depending on the allocator, I may need to pass all the pointers. So yes, that's actually needed. So I can say PTR, right? So this is old pointer. I pass the old size. I can just say old PTR actually. So this old pointer, the old size, the new size, and it's going to return the new pointer. Yeah, this is probably a better signature, to be honest. So this is old pointer, and so on and so forth. Okay, I need to probably change the name of this. I'm going to call it base realloc, because realloc is already taken from libc. So I'm going to say base realloc. Don't worry, I'm going to clean up all of this lib and refactor everything and make it very tidy and well documented in the near future, but for now we're just trying stuff, right, to see whatever actually is required and needed and so on. Okay, so here what is this complaining? Oh yeah, because now since this for each I need to add semicolon here, right? Because I removed the semicolon from the other places. Okay, not a big deal, not a big deal. Same here. Cool. Okay, so here I can implement my realloc. Where is, okay, so I can implement it below the alloc. Okay, so my base realloc is going to be probably similar to the realloc. I'm just going to say if the allocator exists, right, because this is an optional allocator, I can assert that the realloc function also exists, right? And I can basically just pass allocator, the old pointer, the old size bytes, and the new size in bytes. If there is no allocator, for now the default reallocator is going to be realloc as well. So we can just use realloc, and realloc is only going to need the old pointer and the new size. Look at that, new size, right? And this already asserts that everything is fine, and everything will be fine indeed. Okay, so this should in theory work. So let me build and execute, and let's see what this does. Yeah, it works, right? Super simple. So we have just allocated a bunch of strings to our array. This is a dynamic array that grows when needed, and we traverse that array and print the strings in it. We can do more stuff. We can say this is the second version v2, and this is v2, and we are going to have now 6 different strings in it, and it should grow properly, right, as you can see here. So not much to add, it's just super simple. Let me just go through my demo.c file, because I expect it to have things broken, because now I need to add semicolons everywhere. Look at that, right? Because let me just start at the beginning of the file. So every time we have a for each, I actually need to add a semicolon. So this should already fix everything. This keeps complaining. Okay, bucket list. Oh, because I need a semicolon there as well. So another semicolon, another one. As you can see, we had a lot of for each's inside of here. Cool. So that's everything. No, we're actually missing one here. Okay. So for now, I think I can add the demo stuff to my build script. So this is going to be my demo. I can keep everything, and this is going to be demo. Everything else can remain the same, not a big deal. So if I build everything and then I run my demo, the demo is working perfectly fine. We can add a demo for the dynamic array in the future, but I probably want to do the refactor first. Okay, so I guess that's it. From what I was able to implement so far in my base.h file, my collections are going to all have a few functions. So they are going to have appends. This is actually macros, right? But whatever. They are going to have acquire. How do you write it? I wrote it somewhere. This is how you write acquire. So acquire is basically going to be this operation. So instead of providing an element, you provide a pointer, and the collection is going to give you a pointer to a free element. Any pointer, it doesn't need to be the last one, it can be anyone, right? So if you have a bucket list, it's going to give you an empty slot, a pointer to an empty slot, right? If it is a list, it's going to give you a new node. If it is an array, it's going to give you an empty an element that is not being used in that array, right? And so it's going to be append, acquire, and for each. right, for each, and the for each is also going to contain a break, and it's probably also going to need, I think a remove is going to be very good, to be honest. So if you call remove inside the for each, it's going to have the same behavior that Jai has, and it is basically going to remove the current element from the collection, right? So if I can have this collection API for all of the different data structures like list, list array, list, bucket list, array, and bucket array, I think I'm already perfectly fine to implement my game, because this is already like these three operations and these two sub operations are already more than enough, to be honest. Yeah, and for my allocators, I'm probably just going to need the alloc and realloc, to be honest. Oh, and I'm also going to need the free slash reset, right? Free and reset. And I think this is already enough, to be honest. So free is going to, in the case of the pool allocator, is going to release the handle to that specific memory block, and it's going to enable other people to use it. In the case of the linear allocator, it's probably not going to do anything. It's just going to ignore the free call. And reset is going to basically reset the allocator and basically free all of the handles and basically set everything to 0 in terms of usage, right? So it's basically an allocator that has a lot of stuff allocated, but it has a lot of free space actually, right? And I think that's a more than enough good API for now for my game. Alright, so basically in this episode we just implemented my dynamic array, and in the next one we will probably start implementing a tool for building our software in C. So thank you for watching, and I see you in the next one.